Welcome back for your second and final lesson of this week, because we have a nice short week here. We're still going to be talking about multivariable systems of equations, but we're going to make sure that we're not forgetting our word problems. There aren't a ton in 9.3, so I included the 3 also from 9.4. Don't worry about the methods that you see there yet. We're going to do matrices next week, but they're good word problems and you can practice these skills. So, just like before, when we were looking at 2 variables, we're going to think about the questions in terms of every different unit as being its own equation. So in number 1, this is also an opportunity to pause, write things down, set up yourself for guided notes, or print them out. So take that chance with you right now. An investor owns 3 stocks, A, B, and C. The closing prices on 3 days are given below. Despite these changes, the total value of the stocks together remained the same. How many shares of each stock does the investor own? We have the total value of $74,000. So, since it says here how many shares of each stock, that means that those are our variables, which you can kind of see is how it's set up here already for us. So if those are our variables this way, our A term, our B term, and our C term, that's what I mean when I say they're already set up for it, then each of our equations are going to be for the 3 days, right? Again, 3 variables means that we have to have 3 equations in our system to solve. Now, because of the table setup, it's kind of nice to turn them all into an equation because they're all just equal to the total value, which has been told to us is $74,000. So we're going to have 3 equations that all equal that total amount. Right, so here are our 3 equations. Again, you can always pause to write things down in your own time. One thing I would hope that you notice is that when we're looking at our second 2 equations, they have the same C term. So that's really nicely set up for us to cancel out. And this total is going to cancel out. And so if we just subtract these right now, this isn't always going to work, but it's one thing that's helpful about math is just notice when cool patterns show up that make your life easier. So now we have negative 4a plus 5b equals 0. And so we can turn that into a nice simple substitution problem where 5b is equal to 4a. And I ended up, when I was doing this, just solving for b. And so then I get b is equal to 4/5 of a, which is going to be nice to substitute with. So I cleared myself a little space here. You obviously don't need to do that. You have lots more space left. But I put our important conclusion over here. Now I'm going to take those first 2 equations that I had again. So these are the equations for Monday and Tuesday. And I'm going to use substitution here for the B terms using our equation that we just found out. And the nice thing there is that our 25 and our 20 are going to simplify really nicely. So again, I'm going to do a little bit of algebra very fast, and you can pause and catch up. So now we see that we have our A terms here, so we can simplify both of these equations by combining those. Work's getting a little disorganized in this small space. There was a small typo here that I've now fixed. So now we have a 2 variable system, 30a plus 29c and 28a plus 32c. And what I'm going to do is I'm actually not going to eliminate a variable. What I'm going to do is just subtract all of these, and then I'm going to cancel out the totals because, and this is the case that just because they're ready to be canceled out, and I'm going to end up with something very similar to my last system where I've got 2a minus 3c is equal to 0, and using the same logic as I did with b, I then find that c is equal to 2/3 of a. I'm going to make myself some more space. You all don't need to erase. So now that we have these 2 nice substitutions for b and c in terms of a, I'm just going to take one of our original functions and substitute them in. So now we have a lovely equation all in terms of a which we can add these three terms together, which gives us 148 thirds A equals 74,000, which looks gross, but then we grab a calculator and we get the lovely answer of 1,500. And this is always the nice thing. This is actually the third time I tried this problem. This word is going to be even too challenging because the first two times I was just getting weird numbers. And once I found this system, I got very nice answers like this. And that's how one of the ways that I could tell I was probably on the right track, because I don't have the same answer key that you all have. So now that I know that A is 1,500, I can just plug that in here. And I know that in stock B, I have 1,200 shares. And in stock C, there are 1,000. So we've got a slightly different way of solving this system, and hopefully that will help. I also want to do one with percentages, because that was something that some people asked about last week. So here we have one with percentages. Looks like a chemistry problem. A chemist has 3 acid solutions at various concentrations, 10%, 20, and 40. How many milliliters of each should they mix to create 100 milliliters of 18% solution if they want to use up 4 times as much of the 10% as the 40%? So we've got a couple different variables here. And one important thing is that when we're writing a percent one, I think for a lot of you, your first equation would be, let's use just the variables X, Y, and Z here, is that you'd be like, oh, well, 10% of X plus 20% of Y plus 40% of Z, let's make that a percent, that's going to throw everything way off, is equal to 18%. Now, what you'll notice here is this is a percent and amount, plus a percent and an amount, plus a percent and an amount. So you're going to need the same thing over here. The amount that we have in this case, we know we're going to end up with 100. So when we're actually solving this system, we're going to say that 0.1x plus 0.2y plus 0.4z is equal to 18 instead of 0.18. And that's going to give us numbers that actually make sense. The other 2 equations that we're going to have to use, because we have 3 variables here, are that just the quantities together equal 100, similar to this conclusion here, and that we know that the amount of x we want to use is 4 times the amount of z. So the first thing I'm going to do is taking these 2 equations that have all the variables in them, I'm going to substitute in for x using this equation to reduce my problem down by a variable. Again, I'm erasing so you don't have to. Now you'll notice here we've gotten rid of our x variable, and we've got z terms though that can be simplified, so let's just take a second and do that. Now that I've got equations with just y and z, I can use straightforward elimination. I'm going to multiply this top one by 5 to get a y by itself. I'm going to bring that down here. 1y plus 4z is equal to 90. And now our y terms cancel out nicely. And I'm going to bring this up here. We end up with z is equal to 10. So 10 milliliters here. We can use our 4 times as much to tell you that we're going to use 40 milliliters of our 10% solution. And since we know that there's going to be a total of 100, that means the remaining 20% has to be 50 milliliters. So we've seen 2 different kinds of word problems here. This is what we're going to see quizzed on Thursday. So please put any comments in here or come and ask questions in the Zoom meeting. Vote for your favorites. And I hope to hear from you soon. Talk to you later.